Welcome everybody to the DPRG Robot Builders Night Virtual for September 3rd. Tonight, as usual, we're going to do a roundtable, go around with a few people that have updates on their projects. After that, we can go to ad hoc presentations. Anyone steps up in the show or discuss. And as per usual, if you have any questions that you want to try to stop the club, give it your best shot. Let's see if we can answer or help you out. As normal, we record these videos, and the video and the audio is recorded and it's put on our YouTube channel. So if you do not want to be seen or heard, make sure you keep your mic muted and your camera off. And with that, we have our first presenter. He's going to be Mike.
Oh, me. Okay.
Right off the get-go, Mike.
All right. So I guess I'll start with just a show and tell. So that's the robot I've been making. You can sort of see it there. And I'll turn it on. And so she has mechanism wheels, so I can go left and right and forward and reverse, and it can spin. And I also made I put a servo in the head so that she can move her head. And hopefully you can sort of see it.
Yeah, that's cool.
And I added a bumper on it. So if I back her up a little, and so if I try to run her into myself, she humps my foot. if you can sort of see that. Yeah, so it doesn't stop. I was hoping that she would just stop, but she humps like a dog or something. So I changed the motors from coast to braking, and it still didn't stop. But
so, how do you sense that you've bumped?
I think we lost him.
Oh,
hello?
Yeah, I think we did. Oh. How do you sense if you bump into something?
Move that transmitter away, please.
I bought some switches. They look like this.
Oh, okay.
And these are really neat because they detect anything. Like that's a click.
Hey, Mike, move your transmitter
on this,
away from your Wi-Fi antenna.
And if I present my Discord,
move your transmitter, please. The transmitter away from your Wi-Fi.
Oh yeah, I'm gonna turn it off. I did that last time. Thank you.
You were breaking up.
Yeah. So here's my Discord channel that I have. And so I was adding in like the limit switches are here. I don't know if you can see that very well, but I'll give a bigger picture if you want to see it. But basically it's 4 limit switches. I have a bumper circled around the platform. This is on the underside. And it's loosely connected to the top. And then the limit switches are connected to the bumper. And so it can detect movement in any direction.
Oh.
And so the 4 limit switches are in parallel, and they go to both motor controllers to turn them off.
Mm-hmm.
Mike, you might consider like an additional layer of safety is to be monitoring your accelerometers. And if you get a big bump, they act as a, to do the same as a bumper switch.
Ah, yeah, but I don't have any software. It's all hardware. I haven't made any software computers on here yet. I bought one module from GoBuilda, which converts the receiver channels into Bickett wheel.
I got you. So there's no real microprocessor on it.
Yeah, I'm sure there's a microprocessor in that module, but nothing that I have access to control.
Okay, but I'm just saying,
And
you might consider that if you do put one on, just to use the accelerometer to, like, if you suddenly get a pop, it trips the level.
yeah, I plan on my big issue right now is the noise. And what's happening is I had the platform hard connected to the metal base, and so any noise of the gears or the mechanism wheels would vibrate the platform and cause an amplification. It's like a speaker diaphragm. And so right now I'm working on vibration management, and so I put some what do you call it? Let me bring up another picture here. How do I do that?
So are the arms going to move at some future date, or
Pardon?
are the arms going to move? On the
Oh,
pedal?
yeah. The arms will not actively move, but they'll passively move just
okay.
by movement. Yeah.
Yeah. Huh.
So you have a servo in the head? Is that what you said?
Yeah. I think so.
Yes, I put a servo down in that base, the bottom, the bottom pedestal.
Mm-hmm.
So there's a servo down there, and it's just connected to a channel on the receiver to move its head back and forth.
Well, that's good. That's cool. That adds some realism.
Yeah, yeah.
What is the character supposed to be in the play? I'm just curious.
I have no idea.
Okay. Okay. Not your job.
They're still working on it. Let me go to the.
Watch them write her out 2 nights
Okay.
before opening.
Yeah, so
Yeah. After Mike puts on all the effort to write her out.
It's just not working for me.
They better
Just,
not.
director goes, just not working for me.
Right. They better not. Yeah. So I had a picture there of the limit switch.
Yeah,
And
I'm having a little trouble with that, Mike. I'm just, I can see if they hit it from a place where there isn't a limit switch to the side, you know? So you have like 90 degrees, you have a limit switch every 90 degrees. So if they hit it at the 45, I can see where that could trip the limit switch. But if they hit one straight on, you know, right where the limit switch is, does that work? Do you actually see?
Well, if you hit it straight on, then these 2 limit switches here will activate.
Okay, I was curious if it. I'm trying to figure out how the movement works.
Right, and also the limit switch is pretty tightly attached, and so it'll push the if you can sort of see it, it'll when you push it in, it also clicks.
Oh, I got
So-
Oh, it does. Yeah.
So if it gets pushed in, it clicks, and if these move, they click. So probably any movement will activate 2 or 3 limit switches.
You need to also hook up the limit switches to trigger a red LED in her eyes.
Yeah, that would be so easy too.
Yeah.
That'd be cool.
Yeah. Yeah. So this is the close up of the platform, and so I have some window seals, some high density foam window seals that I'm trying to use to help the vibration transfer from the base to the wooden platform.
Mhm.
And it did a pretty good job. It's a lot less. Now this ring is rattling around because it's by design loose. You can't tighten it up, otherwise it wouldn't work. So
Yeah.
yeah,
So how much of this did you get from them? Did they actually have the plastic base and all you had to do was put it on the plywood, or did you have to build up some of the other stuff too?
oh the base. Okay, the base here is the oh, where is it? There it is. So the base I 3D printed, and the motor servo is inside there, and I 3D printed it.
Yeah.
I have pictures. I need to add it to the file,
Mhm.
and then I have a rod that goes up to the head. It goes inside the bigger tube, and there's a pole from the head down to the below the body, and
Mhm.
it's connected to it. And then I put a square post on the servo and a square hole adapter inside the pipe. And so the
Mhm.
servo just moves the head.
Yeah,
Yeah.
got it. Cool.
And I have an emergency switch here to turn it off.
Yeah.
Yeah, to power it off. So that if it actually goes haywire, then an actor can go hit it.
Mhm.
Yeah. So I have a couple safety features on it.
Have you shown it to the theater group yet?
Yeah, the director said it's too loud. Put new wheels on it.
It's what?
So I said, "Oh, I got to go work on the vibration management." Oh, so where am I? Here I am. So stop presenting, and so I have a roll of foam.
It might not be bad.
to attach to the base and staple it on the base and staple it onto the bumper, and that should reduce the bumper vibrations. And I also add a little bit more elasticity, or like a spring, to the bumper to the base to keep the limit switches deactivated when nothing's hitting it.
Mhm.
But right now there's some force in this, there's some springs inside of here, and right now that's all that's keeping the ring centered, and adding that foam on there will add some more spring material to keep it centered. And also I'm going to have the foam go a couple inches past the ring, so that when it gets close to somebody, it'll brush them before it activates the bumper switch.
Yeah.
Could you
That's
suspend the bumper ring below the robot from short wires instead of so that it's actually not in contact with the actual frame, like pendulum?
It's just bolts going through an inch hole.
Yeah, I'm saying it would be quieter if you suspended them from a very short wire instead, that let it flex around, so that it's not it's not going to come into direct contact with the frame it's mounted to.
Yeah.
Oh, I see what you're saying.
Like
Correct.
a gap of like half a centimeter or something like that.
Something.
So it's almost like a pendulum underneath, but on a very
Yeah.
short stroke. Yeah.
Yeah. I guess the limit switches would keep it from moving very much.
Mhm.
Right.
But
Well, sure. So with the tension on the you'd have to choose how many wires to mount it from, but you need at least 3, right? But you might want more.
So you think the vibration wouldn't go through the wire and vibrate the ring as much? But then the limit switches, if the limit switches are hard connected to the base, and then
aren't they going through some sort of collar or something? You just have to lower them a little bit.
Well, they're screwed to the base, but
Mhm. Like
But
you could put
yes,
you could put little spacers under them if you needed to account for the difference in height.
right, and then loosely connect loosely connect the whisker.
Yeah. Yeah, that just needs to go through some sort of grommet like thing.
Yeah.
You must already have that.
Well, I hope I don't have to go there. I hope I can just
Okay.
add on to what I have.
I was just,
Don't make
just
it sound
I
hard,
I was just trying to help you with the director's complaint about the noise.
right. So I'm hoping I can manage it, but if it's like it's still too noisy, then
Is it going to be
I'll
on
be-
a hard wood floor?
I have a wood floor here, a hardwood floor, and it's going to be on a concrete floor during the performance.
Macadams are a little quieter on concrete than they are on hardwood.
But I think it's just the mechanisms cause a vibration, and then that's making the wood vibrate.
Yeah, I know.
Yeah, because the mechanism wheels themselves aren't that noisy, I didn't think. But once I put the platform on it, then it got really noisy.
Yeah, I know the van lifers tend to use this. It's like a sound deadening foam that actually has an adhesive back on it, and they'll put it on kind of like the outside shell of the van on the inside, and that'd probably work pretty good.
So I'm hoping this will absorb the noise and also
Yeah.
stabilize that ring so it doesn't rattle around as much. So
Yeah, there's a certain type of material you can get grommets made out of it. It's the same sort of thing, like vibration isolators. They, I'm not certain what the material is. There's some here somewhere. I don't know where, but
yeah,
He's already using some of that material, something like that for the windows.
Yeah.
Yeah. So right now I'm using. You go grab it here.
they're blue. I know that. That's about it, though.
I'm using foam window seal,
Oh, okay. Yeah.
and it's pretty dense.
Yep.
And so
Yeah, this stuff is specifically made though to dampen vibrations, like on a metal section of inside of a van wall.
yeah, so I'm using these washers, these fender washers, and then I attach this to it,
Mhm.
and then put it below and above the main platform and
Yeah.
screwed it on. And it seemed to do a pretty good job of reducing the noise coming from the platform.
Mhm.
So I'm pretty happy with that.
You might also be able to use some of that foam around the robot base itself to kind of act as a sound dampener from the wheels and stuff. I'm just saying.
Oh,
Like a skirt.
Yeah.
yeah. If it's going up the pedestal up into the puppet.
Well, I was thinking, your motors, the wheels actually going on a concrete floor probably makes a pretty good racket.
Ah, yeah.
And so if you could muffle that, you might get a little lower noise too.
Yeah, I was almost thinking of using this foam here and making it a skirt.
Yeah, that's what kind of what I was thinking, Mike.
Yeah, that'll be my last attempt. That's if I get the platform noise and the bumper noise under control, then I could somehow contain the noise from the wheels and muffle it.
Well, I had some stuff, and basically it's spray rubber. I wonder if the problem is those wheels banging against the concrete floor, or one of the problems, or one of the things that's doing that. If you could put a small coating of the spray rubber on each one of those Mecanim wheels, and I wonder how much you could put on there, and it still act like a Mecanim wheel and give you some more cushion against the initial part where that thing is banging on the concrete. I had some
Not sure I would sign on to that.
Yeah,
That's-
the
that sounds iffy.
Mechanic wheels from
They're
Go
already
Build
rubber.
are relatively soft rubber.
Are they
Yeah.
really? But no, I mean, soft.
They're not.
to me-
They're not plastic. They're rubber. Yeah.
They're like a 90 durometer, something like that.
I mean, they need to be really soft, right? Are they going to make or even just a little bit of noise gets amplified all the way up?
Mechanims don't work when they're super soft because
Well,
they need
maybe
to
I
split.
don't know. My thought was maybe you try something that you don't normally try, because if we were building a robot, we wouldn't do this, right? But if we're building something that needs to look good on stage for 37 seconds, maybe it's okay. That's where I'm going, going with it.
Yeah, if he doesn't need to strafe.
Yeah. Well, the saving grace of this that I don't think the director is thinking of right now is there's going to be a lot of sound from speakers happening during this activity it's going to be doing,
Okay.
and also making it noisy. Like this is an immersive production, which means people are going to be milling around, and the robot's going to be milling around the people, and then there's going to be someone remote controlling it from 20 feet away. So the robot itself, if it makes noise, at least people know it's coming and they'll get out of its way. So I think noise is your friend, just so it's not obnoxious.
But you
Mike,
could
have you thought
also,
about using anti-vibration foam between the plywood base and the motors?
Yeah. So the motors and the metal frame below is really tight, the construction. And so between the metal frame and the plywood, I do have vibrations dampers right now using rubber, using this high density foam. So I put the high density foam on the washers between the plywood and the base, and between the plywood and the washer on the top. And so there's a washer on the top and a washer on the bottom with this squished between it and the plywood. And then the screws it into the base and tighten and squishes down on this rubber stuff. So that's my isolation from the wheels.
but here's another idea, Mike, that you might not have thought of, is you can also use your phone. There's apps that are essentially turn your phone into a noise analyzer. And I mean, and so you can use your phone and tell what your dB level is and see the impact of the different strategies that you're doing.
Yeah, because I figured in my room here, it probably amplifies the noise more than a bigger place that would disperse it more.
I think probably the biggest difference is your floor versus the concrete floor.
Yeah. So what's the venue? What's the venue on this thing?
Well, the location is going to be the Embarcadero building at Fair Park. And so it's basically one of those big areas where you got all those booths that people are selling, hawking stuff at the state fair.
Okay.
Okay. So they have a play going on in the middle of that or something, or a thing going on in the middle of that?
Yeah. So we're going to take over one of the buildings and put audio and video and production and music and
You're not talking about the theater that's end of it that has that horrific World of String.
No.
World of
So we're
String.
not doing the
It's
theater.
a butter sculpture building, isn't it?
That's one of those buildings.
Yeah. So this is just a warehouse, basically. Right now, it looks like a warehouse, and so it's a big empty room, big empty room. And so we gotta decorate it and light it up. Yeah. And basically, it's immersive, so people don't sit in chairs and watch people on a stage. They're part of the performance. So.
Yeah, I don't know if this is used in automotive applications, but there's an example. Anti-vibration pads, they're with an adhesive backing.
So
1/8 of an inch thick.
wow.
You could probably stick several of those around the bottom and take care of your vibration needs.
Huh. Uh-huh.
And you don't even need the Beach Boys. So there you go.
Yeah. Yeah, so it's keeping me busy. So the thing about this project is mechanics and electronics, and I haven't had to do any software yet. So I'm trying not to do software.
I know, right?
Yeah. So I'll continue on my presentation here. Let me I forgot about it. My control logic. Let me share again. Where is it? Okay, so this is my oops, how did I do that? Yeah, get rid of these things. Get rid of. So basically, I have a battery and a relay and a load, which is the load is the motor controllers. And so across the relay, I have a 15 amp reverse diode, so that when the motors are spinning down, like if the relay opens up and the motors spin down, then it gives a path to discharge the energy into the battery to keep from blowing up the electronics. So that's what the 15 amp diode is for. And then this is what I worked on for the pre-charge circuit. So what happens here is when I turn my on switch on, then it powers up, it goes to a 50 ohm resistor, and then goes to the load, and it starts charging up the load. And then when the load gets to about 3.5, 4 volts, the on voltage of the FET, then it powers on the relay and snaps it shut, so it has full power. So that was the way I managed the pre-charge circuit, and it works good. Nothing fancy about it, no software. And then the diode here is the protection diode, reverse protection diode on the relay, so that when the FET opens up, it discharges through the diode here. This one here is one that got me after I tried it, and that is it only allows the pre-charge resistor to hook up when the switch is turned on, because what happened before was once I turned the relay on and then I turned the on-off switch off, the relay stayed on. And there was a path going from the load to the pre-charge resistor, and then going to the relay and keeping it on.
Oh, it was like latching. Yeah.
Yeah, it was latching. So I was like,
Yep.
what the hell?
Yep.
So this diode here keeps it from latching. Yeah. So it's a relatively simple design. I was really happy because I was thinking it's going to be more complicated.
So does RoboClaw recommend a pre-charge circuit like that?
Yeah, they do. They recommend or require it, or I can't remember if the words recommend or require, but it was a strong word. Yeah.
Yeah. Yeah, I know they used to have like your 15 amp diode 1 there across the switch because
they expect this too. Yeah.
You get like inductive kick from the motors, and you don't want to.
Yeah.
Well, I guess some of those are only rated for I think like 34 volts. The RoboClaw units, and
right. Yeah, they're
so
relatively sensitive.
Yep.
Right. Isn't that resistor for when you turn it on that it doesn't have a voltage spike?
This resistor, the 50 ohm,
The pre-charge one is when you turn it on, or
it's to keep the current spike down. Because basically, this has a lot of capacitors in it, and they're discharged. And when you turn the relay on, if you just turn the relay on, then there's a huge current surge occurring.
right?
So what this does is it reduces the current surge until this charges up to 3 or 4 volts, and then it turns the relay on.
Yeah. Okay.
Well, thanks, Mike.
Okay, great.
Are you, were you done?
Yeah. Let me stop or something. Okay. Yeah.
That was a excellent presentation. Thank you. Next up, we had Ray.
Yep.
Ray was voluntold, I think, to do a presentation tonight on his TT motors.
Oh yeah, very exciting. Well, I got 2 of these kits from Harold and some of the parts. Whoops. Got a notice to renew here. Oops. Okay, there we go. Anyway, the kits did not, well, they came with the wheel shaft encoders, which is like, you know, they have 20 slots on them. And I really wanted to, you know, show the kids what it would be like to use better motors that had encoders on the back of the motor, and actually had 2 Pololu, I think these are 20 pulse per revolution encoders, and 3D printed a little adapter basically to go on the back of the motor with a hole in it so the shaft can go through it, and basically hot glued this to the case of the motor, and then hot glued the 2 encoders to the flat surface. I looked up hot glue apparently is a very good insulator, so you can do that. Anyway, I'm realizing now that the TT motors are a pain in the neck. It was kind of curious. I looked at I had 2 others on a very small the challenge line following course contest, and Pololu's not carrying. They've discontinued all those, so I don't know if there was a lot of issues with them or what. But
Wait a minute. Whoa. Are you talking about the micro motors?
they're they're plastic gear motors. They're either white or yellow. If you look at the Pololu website, they're pretty much all discontinued, I think, except one.
They're they don't have encoders, right?
You can put encoders on them like this one.
So they have extended shafts.
Yeah. Like this was one that I used. It's very small. It's just basically an Uno with I could mount the open VH7 on the front, and those 2 spots in the front of the motors here are encoders. And they don't make these anymore, or they don't carry these anymore. They're discontinued. So along with several others. So I wonder if they're too difficult to work with, or, you know, maybe it's just worth buying a little bit more expensive motor that works over a wider range of voltages and all that. But anyway, I spent too much time on this already, just for, you know, it's like
Just
trying to get them something a little bit better than what the kit offered.
Ray, just to clarify, did you glue the rotating magnet onto the very end of the motor shaft?
Oh, yeah, these, I don't know if I can show you this. It's pretty.
Here's mine.
Oh, okay. Yeah, these magnets, let's see if I can, maybe I can light this up a little better. Yeah, the magnets are actually had a little hole in the center, and you just push them on the shaft. I think these were 2 millimeter shafts on the back of the motor, and yeah, they just pushed right on. I don't know if I can.
All right. So the magnets are on the end of the motor shaft as a friction fit. You didn't glue them?
Nope. Yeah, it's just it's friction fit. They're pretty tight.
All right. I only have maybe 1.5 millimeters sticking out the end of the motor on mine.
Yeah.
And I've always been hesitant about putting glue in that area. For very obvious reasons.
Yep.
Hey, Ray, I just
Yeah.
posted a link to Polulu for some white plastic gear motors that they have. It looks like it's $15 for 2 of them, so they're somewhat expensive, but not too bad.
Yeah. Yeah. Anyway, so I went through the different things that you could do online with the encoders on the wheels, and the guy who showed it, I think he did like a 45-minute video of the thing, and it's supposed to, his demonstration was like, drive forward so many centimeters and do a right-hand turn and do a left-hand turn, and the thing was just kind of flailing all over the place. I mean, it isn't, minimal control over the little robot platform. So I was hoping that this would, make the control a little bit better, and with just 20 holes or 40 edges on, at the wheel, you can still do all the, basically you can try to implement all the controls that you can, but with only 20 counts, it's still most likely going to turn in a large arc and not run that smooth. And, but I think for a bunch of teenagers, they'll hopefully enjoy it and have some fun with it and learn a lot. So anyway, that's what I've been doing for the last week or so. Oh yeah, I'm going to try to incorporate Doug's code that he did for this, for some of the programs. One was, I guess, a moth. The other is wall following. I don't remember what the other ones are now.
There was a whole bunch. Oh, I think line following.
Line following, yeah, that's right. Anyway, so at least get it to do some of the simple things that a little platform like this should be able to handle. So anyway, hopefully the little buggers appreciate it.
Yeah.
Well, thanks for the update, Ray.
Sure.
I'm glad you could put them to use, Ray. I truly am.
Yep.
Next up, we have Doug P.
Yeah. Okay. If you guys will, this is kind of like in a part way done. It's not completed. I was going to hold off, but I decided not to. So I got a what do they call it? Not a dumpster dive. Edge of the curb, a curb pickup. And anyway, it's a golf cart. Oh, a thing you roll golf cart with on the course.
Oh, okay. Yeah.
And it's got these, which is what I was looking for.
Big
These
old wheels.
Big ass wheels. So, and they come apart pretty easily. There are 2 bearings in here. So here's what the front, with the hubcap on, and on the back, this looks like, oh wow, they had an encoder or something, but no, that's the brake. They use the brake that pops into one of these notches, and that's how the brake works.
Yeah.
So I made some bearing caps and put them in a wheel. So now I've got, essentially bearings on both sides. And if you see this end, I wanted to make this end. If you look at it, it's like a triangle with bowed legs. Here's my test print, and that fits right in there without any issues. But my intent is to have that done on a flat plate. Let me see if I can find a flat plate. Like this. Okay, so you're going to see a mistake here. You can see this is kind of like what I wanted to do, but why I didn't notice that wasn't the same size as this. Somebody wasn't paying attention. But anyway, so this little piece that I had stuck in here is going to go essentially like that. It'll be one piece. And this thing's going to be drilled out to match this. Okay, so in the end, it looks like this. Okay. And this is going to use your standard power wheel motor. Okay.
Yeah.
But, power wheel motors, they don't have nothing on the end of it. They're like TTL motors when it comes to encoders.
Oh.
And just like Tom was talking about, I think it might be a millimeter and a half stick out.
Oh.
So, I mean, you might be able to do something, but it turns out that our buddies over in China make one with an encoder on it. Okay, it's not the same RPM. But we don't need to go the speed that a power wheel needs to go either. We're not trying. Little kids, they got to go at least 30 miles an hour so they can hit a tree. This one is going to go a little slower than that, but it's so here you can. The only problem is they don't have a pinion gear, so I took the pinion gear off the original motor, stuck it in there, and I don't have the cap on the back, but it works. So I get 60 RPM basically at 12 volts. So and this is a pretty big wheel, so that's pretty fast. And I'm going to try to use the frame of the actual golf cart thing, because it's just a tubular frame, sort of like made out of, think of it like it's constructed kind of like of a bicycle, but not shaped like a bicycle. So I'm going to, it gives me a chance to play with my welder, because they have a very nice caster, but the caster doesn't pivot. It just goes in one direction. I guess when you're doing, I suspect when you're golf carting, you're pulling this behind you, so it doesn't really matter. But I don't know. So, but I was going to see if I could cut that part off and then re-weld a plate on it and basically have a caster with a wheel that's not quite this size, but very close to this size.
Why don't you just make it a balancing robot?
That's too iffy. I know where it would be.
Yep.
I'd hit one of Steve's bumps out on his yard, and I'd go boop. So I'm not going to do that. But anyway, this is an alternative base to the one that I was that I plan to run. So I might run two robots. You know, they'll probably have the same electronics on it, but might have two bases. We'll see how it goes. I was really excited to get this because it looks like adding these power wheels. It's very, very easy to do. So we'll see. And compact too. So it doesn't take much bracketing or anything else to
Yep.
do it. So we'll see how it goes.
So did you plan that with, do yours have, it's like a 1/2 inch shaft that the thing
it's
sits on?
12 millimeters. Yeah.
Oh, it's 12 millimeters. Okay. Yeah. Yeah. I don't know if you ever saw these. That's from Surplus Center. Unfortunately, they don't show like a photo of the flip side here. So yeah, I don't know if that's shaft sticks out at all on the other side there.
Yeah.
But these are like 75 RPM, 12 volt.
Yep.
For $13.
Yep.
I don't know what it would cost for shipping, but yeah, spindle bore. This actually sat on a, well, this says 1/2 inch, which is,
I bet you, since this all comes from China, I would
Yeah.
guarantee you that it's a 12 millimeter.
yeah,
You know, but anyway, yeah, there's a lot of these, a lot of the power wheel motors are available.
yep,
24 volts, but like I say, these look way powerful enough. I don't think that's the problem. I'm just gotta get them together and make sure they run.
yeah. You figure, what does a little kid weigh? Maybe 40, 50 pounds, and
Yeah, but I figure
the weight of the unit and the batteries, and
I bet if you were to look at the specs, they probably have it spec'd out to 150 pounds or something like that.
oh God, you think so?
I think so, probably, or at least 100 pounds. So, but then again, you have a lot of them that they don't run very fast, and people are always whining that it's not going fast enough.
Yeah,
Well, if one little kid can ride on it, if they're boys, 2 little kids can ride on it too
Yeah, that's
at the
true.
same time.
Yeah, I wouldn't be surprised at that too, Harold.
yeah,
So anyway, and plus what I'm doing, I think, I want to say it's going to be so much lighter than that, that it'll,
shouldn't
shouldn't
be an issue. Yeah,
be a problem. And if it
Yeah.
is, hey, it's been fun. I've been having a lot of fun screwing with it. So,
Yeah.
so we'll see how it goes. So I'm planning on to have it'll be a differential robot with encoders and 12 volt based, because just 3S. It'll just be a 3S battery, and we'll see how it goes.
Yep.
So
yeah. The ones that I got were actually, I could put a 3D printed 30 slot wheel on it and use, like an opto interrupter, and so it worked pretty good. You get, I don't know what the gear ratio of the whole gear train is, but there's like 3 separate reducing gears on that, and so yeah, it's pretty torquey.
Yeah. Now when I was decided to buy the motors from AliExpress, I mean, they were like, I'm just going to highball it. I think they were $9 a piece plus shipping. So whatever, probably $12 a piece. And there were alternative ways. I happened, because I was working with Dave Ackley at one time. So I have these little tiny super magnets that are like, I swear they're like 1 millimeter by 3 millimeter or something. I mean, I'm talking about micro, but what Dave was doing was he was drilling little holes and then sticking these magnets in so that he was making his own encoder using these magnets.
Yeah.
And the magnets that size are very, very inexpensive. But so I could have gone that way. You know what I mean? I think I could have made a big wheel. Could have put a wheel on. Could have put magnets on the wheel around the edge. You know, so that.
Yeah.
But I decided that I'd rather have it. If I can get a shaft encoder, I think I'll just go with that.
Doug, I went that way with my outdoor robot. I used 1 millimeter by 5 millimeter magnets inside the hub of one of the wheels. And it's
Yeah.
working quite well.
Yeah, yeah. And yeah, that's, I mean, also on outdoor motors, outdoor rubbers, you don't, depending on how you're going to use the odometry, you don't necessarily need the same resolution that you have for an indoor robot. You know, people, I know Ted could probably tell you this. Is he still here?
Yeah.
Yeah, down at Spark, I want to say at the Spark Fund AVC, they you saw a lot of these
Right.
inside the wheel hub encoders, and so they probably only had. But then again, they were also going pretty fast, so I don't know. But
And I did that myself, putting magnets in the wheel hub, and that works really well. You can even make them quadrature encoders by just using 2 Hall effect sensors and offsetting them.
yeah,
I suppose if you wanted more resolution, you just put more magnets in, more
Yeah.
sensors.
yeah. One thing that's not clear to me, Ted, do you put them all in the same polarity, or do you alternate the polarity?
I alternated them.
Okay.
I put mine all in the same way.
Yeah, I'm trying to think. My first thought was, well, you would put them in all the way.
It depends on your Hall effect
But I
sensor.
think it really depends on your Hall effect, because
I'm using an analog output device.
Yeah.
Some of them will give you 2 different signals. So if it'll detect which way it's going, and that give you a little better resolution, I think.
I figured if I alternated them, then I would cut my pulse ratio in half. I didn't want to do that because it's low enough as it is.
Yeah.
What are you showing us?
Oh, that is a 30 slot little wheel that I think has a shaft that'll fit on the back of those. I forget what you call them. You know, kids' riding toy. The little motor on it.
Hmm.
So it's not very thick, but it's enough to get away from the motor housing, so you can get, you know, either the receiver or the transmitter on one side. And
Yeah, you wonder. I mean, it wouldn't, you know, if they had just given you an extra millimeter or 2 on that shaft, it would be so much easier.
yeah,
But they don't.
You can also buy washers with the magnets built into them. So the washers will have alternating magnetic strips around.
Yeah, I think that's what Ray was using on his little robot he showed earlier.
yeah, on the TT motors.
Yeah.
Yeah, probably.
Yeah,
Because you can buy those at one time. You could buy those little magnets from Polo.
yeah,
You know, you get like 6 magnets for $10 or something like that.
yeah. There's the 2 magnets and 2 encoders. That's a Polulu.
Right. Yeah. There you go.
You can buy just the magnets if you want to.
Yeah, these. Yeah, and these are 20 CPR. I don't know if that changes per revolution. Maybe, I don't know what CPR means, but
Count per revolution.
oh
Yeah.
yeah, it could be counts. Yeah,
That's a count per revolutions.
yeah.
I'm jealous of you guys. Everybody in the US can ship things pretty cheaply across the country. In Canada, we don't generally have anything like that.
Yeah,
Ooh, that hurts.
yeah, yeah.
You know, when you go to buy hey, Palula's got a sale on, order some parts. Well, when the shipping is more than the parts, it's
Right. Yeah.
And unfortunately, Pat lives too far away from the border to use one of the postal stations that are available at border cities. I can
Oh,
use those. It's not too far away, but I don't.
I used to live in Sault Ste. Marie, Ontario, so it was a 2-minute drive to Sault Ste. Marie, Michigan. And yeah, we used a Dropbox all the time in Sault, Michigan.
Yeah, they're very common in Niagara Falls, New York from here.
Niagara Falls. Slowly I turn. Never mind. I guess there's a okay. Ray gets it. Pat might get it. I don't know. Doug maybe get it. Never mind. Never mind.
Doug, were you done?
Yep, that's it. I just wanted to show, how I'm starting to do this particular base. We'll see how it goes. Next week, maybe I can show the actual base. I'll drag it in here and replace my chair or something and point the camera at it. But we'll see how it goes.
Okay, good stuff. Thank you.
Yeah.
Yeah,
Harold.
I had two of those motors on the back of my lawnmower, and I used some old lawnmower wheels, push mower wheels,
Mhm.
and I didn't realize it, but they were so old that the tires were like spinning on the hubs. So it'd get to a point and it looked like nothing was moving, and then you look at the hub and the hub is still spinning, but the tire's just sitting there.
Yeah.
So
Yeah. Well, the guy that owned this golf cart obviously golfed a lot because there is some wear on the tire.
yeah.
I mean, but I'm thinking I might put a TPU retread on it if I have to.
There you go.
Or just a big rubber band.
Yeah. Well, for outdoors, you probably want a little more grip. We'll see how it goes.
Oh,
Harold, you're up next.
awesome. I have to.
Slowly you turn.
I got to put my camera in place. I've been doing a bunch of things on here. So, let me. I'm looking for a gold star. So, I got a kit a while back. Don't remember how long a while was. But if you ever anybody's had ever one of these Key Studio kit, I found it to be really nice. I got this because it was on a whim, AliExpress, something or another. It came up for a special sale, whatever. Somehow it jumped in my cart. Who knew how that happened? And it's been sitting on my shelf over here. And when I was going through all that cleaning stuff, which I just came up and like, hey, I'm waiting for my Tac Attack boards to come back. And so I'm like, hey, let's do something. And this was sitting here, and we've nicknamed this cat Jared Bot because he's a good friend of mine. He's since moved out of the area. And we got to talking, and one of these dimes, he said something. I said, well, yeah, we'll name this Jared Bot after you. And that's how I've been naming all my bots, is whoever was talking to me at the time gets a robot if the thing shows up named after him. So there you go. So it's a real nice kit. By the way, the batteries are on the very, very bottom of this balanced robot, as opposed to being on the very top, the heaviest bits and pieces. So I put it together, and it all went together real fast. Everything came in these nice little boxes and charts and stuff. Well, turns out there's been a little while since this thing came out, but there is a GitHub repo out there that has some of the latest code. And so I will demonstrate. Of course, I had to go make a stand. I basically did one of these things as a flat, and I started poking holes in it in regular kind of intervals, so like that. And before you know it, I had something that looked kind of weird and kind of cool. So I printed it. So you see, I've got no strings, nothing around, and I've been playing with this thing and tweaking on the angle because I'll explain more here in a second. And so I'm going to turn it on. See, you were just balancing, you piece of. No hands, no touching.
Yeah, roll up your sleeves.
Going around.
Nothing up my sleeve.
Not my sleeves. It's not, it's doing it. Oh, if you'll watch it here, I'll get real close there. If you'll watch it here, it's jogging back and forth a little bit. You can see the wheels go back and forth a little bit, but it's maintaining itself fairly good after some serious manual tweaking here. And that's a Zigbee Bluetooth unit, right? And it came along with an application that I side loaded into my phone, which I was crossing fingers, toes, and whatever else I could cross. There wasn't anything truly bad about it. And that phone app does connect up. The original thing from the Play Store, which is supposed to connect up, doesn't. I've got an app. I got a Bluetooth scanner that does connect up, and I can send in an individual command, like I can say F for forward, B for back, L for left, R for right. But of course, it's not exactly fun when you're typing in a terminal and a phone as things doing. The other thing is, currently I get to send one command: forward, back, left, right. And then something goes crazy and it all just spins out of control and nothing comes back. So I suspect there's an underrun error, an overrun error, or some kind of error going on in some of the math. Divide by 0, something causes the program to crash, and it just sits there. And guess what? It goes to the last speed because it's voltage controlled on this thing. Well, it's not necessarily voltage controlled. Here, I'll turn this off. What I mean by nice, we have AB quadricore control encoders on both wheels. We've got some pretty decent spinning wheels here, though. They've got some velocity to them and some again, and you know, the 18650 batteries on the thing. And now one of my problems is that how do I get information back so I can tell what's going on? And I got a 15-foot USB cable I can stick in over to the side, but I haven't had to use that yet because I can't really get much off the bench. Last Friday, we had this thing standing on its own much more without any tweaks or anything. And today when I got in there, I did go put some tweaks in it to do some stuff, which I was surprised about. And so the phone app, if I can pull it up right fast, it's kind of nice. Stop right. It allows you to enter in an angle here. This is the angle, angle 0 of the balance point angle. It doesn't figure out what the balance point angle itself is. You set to what's expected, let it go. You can also set some PID stuff from here. That is if everything worked, and it doesn't, but that's the idea. And it does connect up with Bluetooth. And nice. It does connect up with Bluetooth. So I suspect that this thing is kind of okay. I really don't want to go learn how to write an Android phone app to control this thing, but that's what we got to end up doing. So we got to end up doing. We'll try to make this work as much as we can. It does connect up to this, but this thing is a bit wacky. There's a control switch down here that you don't see. And what it does is, what I'm able to tell is the same serial part that we're reading for our programming is the same serial port this thing uses to send in commands when it's in the terminal thing. So I've got to disconnect the terminal with that little button switch I just switched there in order to program. Then I got to switch it back on. Sometimes I forget to switch it back on, and of course stuff doesn't work, and I get to whine about it. But then when I get it all right, it does work, but it works exactly once. I can tell it to go forward, or I can tell it to go back. But then after it starts going forward or back, it becomes non-responsive. And so I've got some ideas there on why that is. I just don't know how to go about it.
Is that an Uno underneath?
What now?
Is that an Uno underneath?
That, yes, that is an Uno.
Okay, so it's only got one serial port. So you probably, what you should do, Harold, is make a software port, software serial port, just to talk to the application.
Oh yeah, you didn't see what? I hung it up. Wife's talking about this thing back over. If I can.
Yeah, the only problem is it may be kind of hard coded with the shield, which port that uses.
Yeah, the shield for sure is going to want to use whatever serial ports it's plugged into because of the I would suspect.
Okay. Yeah, that's probably true.
And so I got another problem coming too, but it's a wholly different story. So I do like the kit. I thought it was well made. Of course, like any software, it doesn't actually work all the way that I hoped it worked. You know, a little disappointed there. But I've got it's got source code. It actually has 14 different tutorials that walk you through each one of these subsystems, so you make sure that the subsystem works. So that's how I know the Zigbee works, and I know the 6050 is working, and I know the motors are working because we actually go through a tutorial that loads up a sketch to do just those things. So we know we got it connected correctly. And I thought that was real nice of walking everybody through.
Yeah, I like that too. When they test each subsystem.
Yeah, as they go through, right? But then when we put it all together, the common filters that they have in this thing are better than anything I've ever coded up. Because apparently, you know, you see it standing by itself, right? And it's just what I would like to do would have this thing kind of figure out where its set point is. You know, like, okay, we'll start at 0 and we'll wind back and forth until we get to not having to move anywhere and make that my new set point on the fly. And currently this thing this programming doesn't do that. And maybe I can code it up to do that. And then eventually, I don't know how far we'll get, but I'm thinking this is a contender for the next Quick Trip and the next Foursquare. Four Corner.
Non-wheeled one, right? Oh, no, this has got wheels.
Yeah, it's got wheels, but this is a 2-wheeled one. This is a balanced one. This isn't your standard thing, right? So this has got an extra component to it, and so it might be pretty cool. So I don't know how fast it's going to be or not. Yep.
Do you know which IMU is in there?
It's an MPU 6050.
Okay, good. That's what I used in mine. Yeah.
Yeah, and so it's there, and it's not, you know, all the parts are there, and they all do and report like I'd expect them to report. I'm sure it's throwing an error somewhere whenever I use the control button to control it, because if I get up and just check out the control features and have it connected up that way with just the Bluetooth while I'm watching the characters flow through on my serial monitor, every character comes through as you'd expected. It's a little bit it's not as responsive as I'd like it to be, but it does respond. Sometimes it takes a couple of press on the phone, and maybe that's got something to do with the app on the phone. I don't know.
So I assume you know which H-bridge devices it's got, right? You can see those. So, you know, there's dozens of software packages that run with exactly that hardware configuration.
Yeah.
So you can actually go pick up a few more and try them out.
We can certainly try that.
Configure the IO, and that's all.
Yeah, we can certainly try that. I hadn't thought about that. Maybe we go find that, because there's got to be a bunch of these things. Most of them, this one actually did a pretty good job. What I found that most of these things I've looked at before, you ask them, how did you come up with the settings for the PID, right? And how did you do this? And how did you do that? And a lot of times the answer comes back, I don't know. It was just in the code I got, and it happened to work, and whatever it was. And I'm like, I think there was literally one of these programs written back in 2005, and everybody else has copied it since. And that's, you know, but it's you know, that's okay. I need to understand better what's going on. And this has been the best of the ones I've come with a kit, and I can go look for some more, because I'm pretty certain we're not because it's using I've got an MPU 6050.H that comes straight up from some they included the library in the zip package that I got from them. But it looks like just not their version, but they just zipped up a package and stuck it in the file along with it, so we didn't have to go download it. That's what it looks like. There's some timer thing, there's some pin change or whatever, but I suspect they're doing what you just decided to do. This pin change.h takes whatever pin they were having on some other thing and converts it to whatever they're using here from other software that they got a hold of. I suspect that's what it is. I don't know for sure. The PWM works. It's got the wire thing. So we're doing I2C communications over the thing when we're talking between the Uno and the shield that's up here doing various bits. It's got a button on the thing that beeps, and the whole beeps the speaker, does all the stuff, and it's coming really close. But here's the real problem with getting to this thing to further along down the way. The problem is that it's coming. I promise it's coming. Did I show you these last time? Maybe I did, maybe I didn't. The problem is these showed up. Now this is my first PCB board. I'm calling it Tac Attack because we're going to make this some phaser looking thing for doing a tachometer deal. If I can get up, let's make sure I get over to the thing. They came out and they came out really, really nice. At least I think they're really, really nice. You plug in the tachometer, the IR receiver up here at the beginning, and we'll have one of those OLED displays that plug in. A Nano V3 right there. I got places for capacitors for line voltage sorts of things. I got two buttons, one for on and off, and the other one for a trigger. And at the front, I've got some pretty much a debouncing capacitor at the front of this thing that plug into the deal, and ends up being two-sided. And there is ground plane everywhere I could put ground plane. I didn't take off any more copper than I actually had. And this was with KiCad. Yeah, and it went in and literally cost me $5 for 10 of these, $5.63 for 10 of these things manufactured and shipped my way. And I will tell you, this is way easier than I thought it was going to be. And they came out pretty nice. And tomorrow night we'll be putting these things together and seeing how well they work. I've got all the headers and the capacitors. And in fact, I think I've mislabeled one of these capacitors. That I've got microfarads, and I think I've got nanofarads here at the house. So we're just going to put in 1 nanofarad, see what happens, because these two capacitors are in parallel. And if that's the work, then we'll update the board. So the next time we print these, if I have to, I'll do it. We'll print them a different way and update the stuff. And so this is way cool. I was going to make some cool shape and design here, but I figured out for my first board and everything, if I get one back that worked, we're going to roll with that. We're going to roll with that.
You look good.
So it may be a little bit before we hit this guy again, because I need to do a 3D model to fit this in for a case. I want it snap fit, and I want it to look. I want to be inspired by Star Trek in a handheld, little, not one of the big gun phasers, but one of the other kind of phasers on it. We'll see if I get. I'm just not going to look like one of those, but hopefully I want to use some inspiration for one of those and see if we can do something on the modeling thing. So that's the real problem with this thing not working, is because I got something else to play with. So, yeah.
Distractions.
Yeah, exactly. And I this was easy enough that I don't, and because it was my first one, I got a $5 coupon. If I got a $5 coupon, this would have cost me with shipping, and it came in like a week and a half, not quite 2 weeks, from China, because most of that was shipping from China, on a boat, wherever, how long that took. And it would have cost me $10.63 without the discount on it. And so I figure $1 a board and it's a nice looking board, and it was simple enough where I don't know I could mess it up too terribly bad.
I'm just a little curious. Did you get this from JCL Lab or
PCB Way.
PCB?
And the reason I got it from PCB Way, it's not like I was married to any of these people. The reason I got it from PCB Way is camera down. The reason I got it from PCB Way is because they provide a plug-in to KiCad that when you get ready and you get looking, you've already done all your checks and done all the stuff, and you're happy to see what you see. You hit this little button, and this little button bundles up all the stuff, calls a web page, uploads your file to that web page, sets a bunch of settings that it figures you already need, and then says, here, change what you want to change. And so I changed it from the green PCB to the blue with the white lettering and a couple of other minor things, because I don't really need to change much, because we don't need to increase the width of the voltage of the positive feed, just because we're not pushing that much current. We're pushing more. The normal widths are more than wide enough to push everything we need to push on here. And then so I went through all those to make sure that understood a little bit. There's a whole bunch of stuff I have no idea what it does, but it was able to do that. I clicked to go, and I had to wait around, I guess maybe I don't know, it might have been maybe an hour, maybe two, after I published it, that it got into their house over there. Somebody reviewed the design, approved it, and said, pay for it, we'll make it for you and ship it to you. It was easy. That's why I went,
So do they still, what is the other one that, the one that has easy EDA? Is
that's JLC PCB is one of them. And that easy EDA is starts with an L or something. They use an L thing. I had it on this laptop. I don't have it now. What do we get rid of it?
All I'm saying is, looking at that, you could, they offer 100 by 100.
Yep.
And that one is, you can panel them. So,
yeah.
I think I had a board that I paneled, and I ended up with like 25 or 50 of them. I didn't need that many, but I was trying to make the board small, so it paneled up real nice. And that's real easy to do in KiCad.
Yeah. This board here is 100, just under 100 by 30 or something like that. And so I wanted to get down to the 100, and so it fit within the parameters for cheap. The only thing I was really mad about is I like the blue. I didn't want to do green because everybody does green, They had yellow. I get black, and I can get white, and then put black lettering on it. But if I wanted my purple to match, hello, HP, where's my purples? That the price went from $10.63 to $38.50. And I'm like, really?
I don't buy a lot of PCBs online, but when I do, I tend to look at the surveys and I pick a one that's different from the last one I used, because what I'm really looking for is another first-time user discount.
Oh, there you go.
My last 10 boards cost me $2 Canadian.
If it's in the game, it's in the game, right? So don't hate the player, If it's so that's a good way to play this particular game. I may do that. I mean, that might be a good idea.
They all make good boards, so there's nothing to worry about. And deliveries all appear to be really fast now. And I use the default bottom of the shipping list, so I don't have to pay extra.
Yeah. I could have probably had these with 3 or 4 days if I didn't mind paying an extra $20 for shipping. And I didn't want, it wasn't that important to me. It just wasn't.
So what do you think it would cost you, say about that, 10 more boards? Is it going to cost you twice as much, or because it's your second time, or?
I bet if I go in here and I get these boards again, like I were to go reorder them, I could try.
Yeah.
I bet it's going to cost me another $10.63.
Oh, really? Okay.
Because the only discount I truly got was the $5 off discount for being a first time buyer.
Okay.
At least that's the only discount that showed up on the list of stuff.
Mm.
Yeah,
I
but
just got the board I just showed.
And the reason I ordered 10 of them is because when I ordered 5 of them, I got a discount. They said what it was. So I said, what happens if I order 10 of them? The price didn't go up at all. So we're ordering 10 of them.
yeah, well, that's like paneling them with JLC PCB. You could have gotten 3 per board. So you would end up with 15 for their bottom.
Yeah, I
$5.
didn't think about that. So if you take this thing out, let me go back to the thing. So if we take this and do one of these things and put some heavy cut lines in there that we're going to just snap them apart, right?
Yep.
Something like that. That would have been 100 by 100 pretty much.
Yeah.
And I could have got that board for probably $5.83 and split them apart. You'd
You got 15 for $5.
Yeah.
But that's
I may try that trick next time when I'm putting.
Yeah. You know, like I said,
I'm putting combine Tom's game plan with Doug's game plan, and there you go, make your millions.
Yeah.
Yeah. But anyway, I was real pleased with the whole situation as it came out. It took KiCad, took a little bit, much like when you were talking about the other day, the other meeting when your Design Spark Mechanical versus Onshape versus the Fusion that I use versus the bamboo thing that bamboo slicer, bamboo studio that I use. They all want to work in free space and they all want to work a little bit differently. So my brain has to reconfigure itself until I get used to being in the space, and then I'm in the space. Everything worked pretty easy. I was actually surprised. Also, there's another thing out there called free routing. It's that plug-in.
Yeah, I use it.
It did a really good job.
Yeah,
I mean, I didn't have much of a job to do, but what it did, I thought it was a good job.
Free routing is definitely at least for most of us, that's the way to go. And I'd say then you go touch it up when you.
Then Doug, I took some of your advice and touched it up, and the little short, like when you got a 45 comes in and a little short into the pad, screw that, just go right into the pad, and then give me a little extra space and things like that.
See this, Harold?
Yes, sir.
That's a little circuit that I made, and I got 15 per 100 millim, whatever it is.
Yeah.
And so I ended up, like I said, with more of these than I'll ever use in my lifetime. I'm going to handle, I've been using this to practice some of my soldering skills, and I plan to hand them out at the next meeting.
Cool.
They're reverse polarity protectors. So you can literally, and they're like at 30 amps, so they're pretty hefty. So
if I hook it up the wrong way, is a little light lights up to tell me don't be stupid, you moron, or is that
no, just nothing happens. You have no voltage.
okay?
Otherwise, you put this in front of your board, and if you get it wrong, if you hook your battery in wrong, nothing happens. If you get it right, you get power.
You get power. Okay, cool.
Yeah. So
that's one thing I didn't do on this board, that I'm relying on the IR transmitter receiver, because it has an LED power light on it. So when it receives power, a light comes on. And that's the one thing that I did not do specifically on this board, was to put in an LED just that says I've got power coming. VN is hot. Basically, is what I'd like to do, and I did not do it on this board. I did not know about that until after I'd sent it in, and but the board that has the IR on it does have that, so we're gonna have it do double duty.
From what I've seen on the PC boards, though, they follow the Dave Ackley rule of 3. It's the third one that you make. The third time through is when it works the way you want it to. So the first one you do it probably 95% works. And you say, well, that's not quite right. This is not quite right. The second one, you fix some of them, but you uncover the next layer of problems. And then on the third one, they actually work. So that's.
I've already seen some places on this where, again, I've got a bunch of ceramic caps, and I've said 100 mics and a 0.01 mic in here to do on my voltages that coming in for a voltage stabilization sort of thing. And the actual circuit that I just grabbed a random cap I had on here and I jammed it into the breadboard. Turns out that's not 100 mics, it's 100 nano. And then, so I've got to change a thing, but it works. Mm-hmm. So I'm like, okay, so we're going to try those, and maybe I don't need that extra capacitor in there. I have no idea exactly why you would want two capacitors in parallel between.
It's to suppress. Okay, the small capacitor is usually meant there to suppress the high frequency.
High frequencies. I got you.
The low capacitor, the bigger capacitor.
I said I had no idea. I thought it was something like that, but I didn't bother. It's been a long time since I had AC DC circuits, and I didn't want to go pull up my textbook from upstairs and go look that up, work that problem.
Yeah, you want to have bypass capacitors distributed through your board, but you don't necessarily need the bigger capacitor, but probably at one place.
Yeah, and that's and so I don't have a whole lot of things, and I don't know how I'm going to mount this thing quite yet, but we'll work through that tomorrow. My idea is that I'm going to, before I go to bed tonight, I'm going to make sure I've got all the parts. Like I said, I had all the parts, and get ready, and we'll be soldering the boards up and putting some things on and turning things on, and hopefully we don't let the smoke out, and it actually measures something. And I even have some wheels here that I can turn on. I even got some wheels here that I could turn on and put a piece of tape on them, to see if see what the RPM says. Because how I made sure these work is I put a piece of wheel on a tape. I put a piece of tape on a wheel on a motor that says it's rated at 190 RPMs. And when I ran the code that I got, it read 192 RPMs. And I'm like, margin of error, that's pretty good. I'll take it. And
as much as I trust the electronics I use and the math I use to determine wheel speeds, one of the most useful things I own for robots is this handheld tech.
Yes. And this is where it came. This is where it came, Thomas. I wanted one of those. And I said, I can go spend $40 or at the very least to get a kind of a decent one, because I watched some YouTube videos and saw some people reviewing some of these things. And then I saw this one video. It's like, hey, you can do all these things. And look, I found a bunch of weirdnesses going on all these handheld ones that I bought and I paid a lot of money for. And I'm like, well, if I want to get errors out of the ones I paid a lot of money for, and I looked and see what was in it, well, why don't I build my own, and then we can see what those errors are and learn something at the same time. And this is a simple enough circuit that I bet I can do this KiCad thing, or KiCad. I don't know what you're supposed to call the damn thing, and that's how this project came about, on me doing that. Kind of like, because I saw the same thing, man. I don't know. The other thing is the other thing we can measure here with these wheels, this has quadrature encoders on it, right? So, am I doing that right? That. See, that thing's got quadrature control, and I can load in a sketch and tell it to monitor the wheel speed, and it'll tell me what the wheel speed is, because the encoders, and we can certainly point that tachometer that we are going on there and see how close it is. Yeah. We got some good way to measure it on both sides of the equation, so to speak. Yeah. So anyway, that's I know I ran on for a long time. That's about all I have about other things and stuff. I know some of you might be able to tell. I'm actually cleaning up. I'm reorganizing the lab in my garage, so it's hanging artwork and putting things in buckets and throwing them on shelves and labeling so that I'm a little bit more organized in things that I do. And I find that I got to be careful with that because I can get into my high C world and start organizing, and that's all I ever do is organize. I never really build anything that's fun. So it comes in waves, I suppose. Yeah.
Well, thanks, Harold.
You're welcome. I hope it's at least a little entertaining.
Oh, hey, definitely. He's covered
You know?
several different things you're working on. That
Yeah.
was good. I've got one I could show. I did show earlier my foray into PCB boards. So I had those made as well. And as you guys were saying, I ordered 5 of them and they came to the house. I think it was $5.21 out of China, Canadian. And they came in under 2 weeks. It wasn't bad. While I was waiting, I also discovered a mistake I made. I got the USB power is connected through to the 5-volt regulator power. And so I remade the board with those two separated so that the 5 volts aren't combined at all. So we'll see when those guys show up. They're in our local area, so they should be showing up tomorrow. I'm guessing they were in Sudbury today. So we'll see how that goes. Also, share a screen. So I bought these guys.
yeah.
I was impressed with Ray's demo that he put on a few weeks ago.
Yep.
So I purchased a couple of these guys, the A010 model, and to see what I could do with it and how it would work as a distance sensor.
Mhm.
Essentially, looking out at a 45-degree angle or so at the front of a robot.
Yep.
And to give you wide coverage for, leafy shaped obstacles that could be in your path, things like that.
Mhm. Yep. Supposed to
So-
work outside.
It's supposed to work outside. So I am trying to find where I am here. Too many different windows open. So I have wrote up a little Python script and parse out the data and see how it goes just over USB. Fairly simple little script. And I don't have any live data to show you because it's hooked up to my other computer. But I was able to parse out the data. And when I'm watching it, the display, and you can see better when the display is changing. You can sort of make out the shape, the closer stuff versus the far stuff. Anything far away is at max distance will be FF, 0xFF. And then anything closer up will be changed. So you can see the difference in the writing, and it sort of matches the picture. I've got it scaled down to 25 by 25.
Yep.
Because I don't think I needed a 100 by 100.
Yeah, it's a lot more data.
A lot more data. What I did find is that, so as you can see, I'm grabbing a frame number. My frame number is different than their frame number because my frame number depends on when I start my routine. Their frame number is these two guys. It depends on when the camera was started. So they are different and they're in little endian. So 6C12 would be that guy. And then I parse him out into a data table just to see what I could do with him. So far, I'm running easily 20 frames a second, but that's on my computer, reading the data and going through. So I've been toying with the idea of putting it onto either the Raspberry Pi or putting it into just a little Pico board or something, an RP2040, and seeing what I can do. I'd like to have both of them in there and possibly have it just extract, the closest object that's of a certain, certain size, certain number of pixels.
Hey, Pat?
Yes.
Okay, a couple of things here. So I'm assuming that the max range is 224 centimeters based on the Excel worksheet in the background.
Yeah, so that's I was playing with in the background. So the shortest reading I get is 23 hex. And 23 hex is 35 decimal. And when I was measuring, I know that I was about 4 centimeters away when I was getting
Okay.
down to 23.
Okay.
So that's where I just did some quick dirty math. Minus 31 gives me my 4 centimeters.
Mhm.
And so then I started experimenting with other distances. So I pointed it up to the ceiling, just a big blank ceiling.
Yeah.
How far away? It was about 1.7 meters, maybe 1.6, maybe 1.8. I don't know, 1.5. But it was somewhere in that ballpark.
Can you do a grab of those 12, those 5, those 10 cells and just do a insert graph?
In these guys?
The deck and the centimeters, just grab those. Okay. Now to go to insert, graph, chart.
Yeah.
Okay. And do XY scatter, I think.
XY scatter or line?
You can try a line. Either one of those probably ought to work. Let's see what happens. Okay.
Looks pretty linear.
Yeah, it looks pretty good.
So I don't know. That's just what I did quickly to as a test.
Yeah, just for grins, go ahead and do an XY chart. Just go up and change, grab them again. Yeah, and you can include the deck in the CMS. It'll use them as titles.
Okay,
Or axes labels.
you want me to do a scatter with this one?
Yeah. Because now you have, I don't know, okay, CMS. So.
Yeah, so it put the other one, it put the CMS as centimeters as vertical and decimal as horizontal.
Mm-hmm. Okay. All right. I just playing with it. Okay. So, hey, can you put the link for that? I must have missed that when Ray showed that. It looked like it was a Max Sense or something.
Yeah, it's a Max Sense
A010.
Can you put a link in the chat, please?
Yeah.
Yeah, I can. Let me look back to my. Okay. Too many windows open. This is a big long link.
That's okay.
Yeah.
That's got that's where they've embedded your credit card number, and we'll just use it.
Yes, exactly.
Yeah, I was even thinking of just looking at one line of the data, say, like a real quick, is anything too close kind of thing,
Mm-hmm. Now,
yeah, that's. I'm toying with
this,
OpenCV on a like a little Pi board. So throw OpenCV in there, read it into as an image array, and just put a kernel on it, and try to find the closest thing you can.
Yeah.
can this
I
work?
actually got it to talk to an OpenMV H7, and I could display the image in black and white on the screen. Of course, it's at 25 by 25. It's just a little portion of the corner of the screen because that's pretty small. But it did work. So, and that's about as far as I got with it.
So, does it work outside?
I haven't tried it outside yet.
It's supposed to. They say it does. They show two guys walking away from it, and it shows in, you know, a distance of their backs, basically.
Mm-hmm. That's cool.
So,
I have some shrubs in the backyard is what I want to test it with for,
Mm-hmm.
yeah.
I
like
think
that
that 100 by 100, is that what it is? You said?
it's up to 100 by 100.
Yeah, that would be really good for
25.
detecting scattered targets, I think.
Yep.
Yeah, so it essentially just gives you a distance-based data coming back.
Mm-hmm.
Right.
How frequently? What's it?
Well, that's the weird thing is that so I've told it to give me while testing 1 frame per second, and I get like 10 plus frames per second is what I'm getting on it. So
Yeah, I want to say
I found that
do
strange.
20.
What's that?
I thought it would do like 20 frames a second.
It's really interesting. Depending on what document you're reading, some of it says 20, some of it says 1 to 19, some of it says 1 to 20.
Yeah.
And all of it, I find that the frequency that I'm reading the serial data, if I parse out and I get my header information and I read the serial data
Yeah.
as fast as I can, I get way more than 1 frame per second that I'm calling for.
Okay.
And,
So are
and
you reading
I
it?
notice the data is changing.
Are you reading it at the whatever it is, 900,061 baud?
No,
or-
I'm reading it at 115, 200.
Oh, okay. Yeah, when I did it, I don't know what the number is. It's like 900,000 something baud, but the OpenMVH7 would keep up with it. So
Yeah, I did notice that at 115, 200, occasionally I will miss a frame
okay, yeah,
sporadically. And like I say, I don't know if I would read it at 20 frames per second. I'd probably be reading it at 10 frames a second or something.
yep. Yeah, so 25 by 25 is only 625 bytes. So
Yeah, 625 bytes. And so when I read it, I've got a data length of 641. So you read the header, gives you 2 bytes.
right.
And you read your other data. And in your other data, you end up with the length,
Mm-hmm.
and which is
Did you guys get this off of Alley or some weird store?
Yeah.
I
Yep.
bought it off of Ali because Cypede was out of stock. I went to AliExpress to the Cypede store and I ordered it there.
How much is it?
$483 Canadian.
Oh,
I
that's
think
not
it's
good.
$39 US.
39? That's not too
Yeah,
bad.
it's dirt cheap, really.
I had 2 of them Canadian was $81.
Mm-hmm.
Yeah.
So what do you know what its field of its horizontal field of view is?
It
I
says,
thought
I
it
don't
was
remember.
70 degrees.
Hmm?
I thought it was 70 degrees.
Wow.
Yeah.
That's pretty good. Boy, we live in good times, guys.
Oh, yeah. The only thing, the bad part is the programmer.
Yeah.
That's me.
Mm.
Field of view, 70 horizontal, 60 vertical.
Well, you wouldn't need many of those to cover your front.
No, and I figured I'm not looking for an obstacle directly in front. I'm looking for an obstacle essentially in front of the wheels. So I may have some overlap
Mm-hmm.
when I place them. I figure if the front of the robot goes through, I don't care to the side. So they won't be at a 45-degree angle. They'll be, 35 off center or something with an overlap on the 70 degrees and
Mm-hmm.
deal with it that way.
Wow.
Yeah, I know the OpenMV H7 doesn't like the whatever it is. It's like a vertical cavity laser thing that spits out the dots, and it does something weird to the auto white balance there. It's like it starts getting a beat frequency going with it or something. I don't know. It's weird. But
Oh, really? So you've noticed that it's giving you a problem with your other camera?
yeah, I think though if you put the A010 in front of the other camera so you can't see it, it's okay. But yeah, if you get it so it's like shining like at an angle towards it or something, it does weird things. So
Interesting.
but
We'll have to see anyway. So
Yep.
I'm looking to see how I could connect it. So right now I got it by USB. Ray, did you say how you did when you did your test? Do you remember how many amps, like micro milliamps it drew?
No, I don't. Yeah, I got it here.
It's saying 5 volts, half an amp, but I didn't think it was that much for some reason.
Yeah, I can plug mine in and see.
Hey, Pat, the code you were showing, are you running that on a Raspberry Pi?
No, I'm running that on my Linux PC.
Oh, okay. I was wondering if you tried it on a ESP32 or something. I was just curious.
No, I have not. I'd like to try it on, like I say, I'm hoping to be able to port it to MicroPython on something.
Yeah.
Something with 2 serial ports, let's say.
Mm-hmm.
But I haven't done that as of yet. So when I look up the specs on that camera, it says frame rate up to 30 frames per second.
Hmm.
So, and like I say, so their documentation is all over the place on some of this stuff.
Mm-hmm.
Yeah, you gotta love that up to, right?
Yeah.
Well, just plugged in. My little USB meter says 100 and let's see. Okay, yeah, about 100 milliamps,
Okay.
and it's
Oh.
running.
It may have spikes. Maybe that's why they're calling for a half amp supply.
Yeah.
Well, thanks,
Okay.
Ray.
Yeah, this one right now it's showing me the frames per second. It's 15. It's in 100 by 100 mode. So.
Which I found was interesting. When I put it in 1 frame per second, the LCD display was updating at 1 frame per second. But when I
really?
looked, the data coming over the serial port was updating at much, much higher than 1 frame per second.
Hmm.
And you could see when you turned the camera, you could clearly see that whole setup I had, where you could see the picture panning from one side to the other in the data. So it's interesting.
Yeah, they were saying, America, we're great innovators, and then you look at the stuff that you can buy from China for dirt cheap, and it's like, oh, I don't know about that.
Yeah, because they copied
Including electric cars, apparently.
I don't know anybody that offered something like that here, especially for that price. I mean,
Yes, I first ran into that when I moved up to digital 2.4 gig radio controls. I really wanted to buy from the local hobby stores, right, and support them. But when they want literally 10 times more than I can buy it online, I said, my God, I went to them and said, what's the value add here?
Yeah.
They're friendly face.
They're paying for the brick and mortar, I guess.
Well, and unfortunately, I know a hell of a lot more about the technology than the guy behind the counter does.
Yeah, and sometimes I will tell you, as much as I've gotten help from the local hobby town, and they've been very informative and very helpful, I've had an equal amount of times where I got the person that looked at me like I was an idiot and provided like almost no help. I don't know if you could provide negative help, but it wasn't a comfortable experience when he found out that I'm not using this thing and I'm not doing XYZ cool race car or flight. I want to do something else or something different than they just kind of shut down. Some of them get excited, but most of the time that's not what I found.
And if you ask some of the American companies, they'll tell you the Chinese straight up steal their work, and so could have something to do with it.
Yeah. Well, I mean, I want to buy from them. Like I'm just, I want to buy from them. I want this thing, and either they don't have it, or they can't get it, or they said they're not going to get it, or it takes them 3 weeks to get it. I'm like, well, I can get it here in 2 weeks, and it's 10 times cheaper. I would pay the extra price if they just had the thing when I needed it. Much like, okay, I'm going to bring up Tanner's. Tanner's been inexpensive in a lot of ways, but its biggest value to me was it had something I needed, and they had it, and I got it. I didn't, whatever it was going to cost was going to be pale in comparison to me getting it today, so I could go home and fix whatever I need to fix.
Pat, did you have anything else on your list of?
That is what I had on my list. I did have a question. I don't know if Kareem is still online. He's been showing his tabletop. I didn't know if he wanted to talk about what he was working on. I did see something with wheels earlier.
I'll talk about it next weekend if I can find the right batteries for it.
Okay, thanks, Kareem. It looked cool. That's why I was asking. So,
well, I can spend a minute or two and show you the current status of the encoder project I'm working on, if you'd like.
Sure.
You're all familiar with radio controls that look like this. I have several sets I bought used cheap, and that's what I'm going to use as the remote control for my outdoor robot, since it requires some form of failsafe, and I like to have a fallback anyway. So I'm just going to share a screen here if I can find it. Is that now? Window. This one. Since we're talking about radio controls, I assume you can see that. That happens to be the guts of the receiver for this little 3-channel Surface 2.4 gig radio system. It has a conventional 3-channel output. This is pulse width modulation. I want pulse position modulation, single wire, not 3 wires, to go run into my ESP32. So I pulled this thing apart and probed around a bit with my scope, just in case this fancy module already had pulse position modulation coming out of it, which is fairly common if the stuff's not too old. Unfortunately, this one doesn't. And just by the by, there's only 2 chips here. This is a Cypress radio control chip, which does most of the heavy lifting. This little gem up here is an Atmel 168. Very, very common, so I felt very comfortable probing it. It still doesn't have pulse position modulation coming out of it, unfortunately. I don't know what all the other signals are for. So the goal was, and I just took a few notes here, my rough notes from my work as I worked on this. Browsing around the internet, it became clear that some people do this conversion using a passive circuit. So I built one. That's that upper circuit on the perf board. Basically, it's a wired OR circuit. Now, because I'm using a relatively recent all-digital design for the receiver, the pulse width modulation pulses come out of the receiver with essentially no gap between the trailing end of channel 1 and the lead edge of channel 2. And these passive circuits, it turns out, only work when there's a gap between these, which is characteristic of very old designs that used to use explicit shift registers to produce these. So after messing around with this a lot and attempting to stick some RC filters to delay the leading edge of the next pulse to get enough of a gap in here, and doing a bunch of other messing around, this was the best I could get, is this middle circuit. I could get these really, really narrow transitions that never really went down low enough, and they had really terrible RC curves on them, really, really bad time constant curves. So I finally abandoned this whole mess when I could not get reliable decoding inside the ESP32 with the MicroPython code that I was using. The code works fine, except that the signals are pretty messy. Hence, I started to take a look at building a proper solution using some digital circuitry. This particular gadget is the one I'm using, and it basically hooks up to the pulse width modulation outputs and produces a single output that goes to the ESP32. I'm happen to be using a DigiSpark. There's a picture of a DigiSpark. These things are pretty nice, and I have a bag full of them, and I've been looking for a use for them. It's an 8-bit Atmel AT-Tiny 85. I've used them in several other projects before. They're pretty cool. So I've implemented all the code. I'm at the point where I will test it soon. The interesting thing about the code is that there's essentially nothing in the main loop of the Arduino C++ code that I'll be putting on this thing. It's all interrupt driven. So you take advantage of pin change interrupts on the inputs, and you take advantage of the timer counters in order to produce the one-shot pulses on the output. And I also threw in a loss of signal detector as well, a timeout detector, because it was easy. So we'll see how this thing works. These things, at the time I bought them, they were probably 70 or 80 cents each. So I bought a bunch. Now I'm looking for uses for them. Anyway, we'll see how this works. And maybe next week I'll be able to show you some actual waveforms from my scope showing how well it's working. We'll see. That was it.
So pulse position, do you have like a start frame, and then where we see a pulse so far down that says something happened on that channel or something?
Ray, see the very bottom waveform here?
Yep.
That's pulse position modulation.
Okay.
It basically says at the beginning of the channel 1 pulse that you'd normally associate with a an old school pulse width modulation, at the very beginning, the leading edge of that pulse, you produce a pulse here, which officially is 300 microseconds long, although many manufacturers have wide variation on what they produce. But nominally, it's 300 microseconds.
What?
So when you come to the leading edge of channel 2, you produce a second pulse. When you come to the leading edge of channel 3, you produce the third pulse.
These are you talking about? Is this supposed to be for a radio input where you're taking the channel inputs from the radio?
I'm just trying to clarify what you said, Doug. What this does is it takes the pulse width modulation signals out of the radio control receiver,
Right.
and inputs them in serial form into the digital inputs of an
That's the old
ESP32.
style way of doing things. Yeah, they did it that way. They used to just have one big string with all 8 channels on them. And
Right.
but if you go up to the top one, you don't get those pulses again for some period of time. Probably if it was by spec, it'd be 20 milliseconds.
And they refer to that as a frame, Doug. And the
Yeah, I know,
frame
but I'm just
repetition
saying,
rate
you're
is
not
about
showing
once
it.
every 20 milliseconds.
Right. But they don't necessarily follow that. A lot of the new ones are like 10 or 12 milliseconds.
But this isn't a new one. I'm dealing with what I've got.
Okay.
Right?
So, yeah, I've seen code for doing that.
Sure, lots of code.
Yeah, I mean, that's.
But the code doesn't use the hardware I've got. So I have to modify it. And by the time I was done modifying it and fixing a few problems in it, it looks a fair bit different. So
Okay. Well,
you find code off the internet, guess what? It's got problems.
well, no, okay, maybe I've been lucky. I've done this at least in Arduino boards without any issue.
Sure.
many
But,
times.
but I'm a bit of a purist, and this is unusual code. Like I said, this is all interrupt driven.
Well, it
Pretty
would be.
unusual when you're programming Arduinos.
No, it would be interrupt driven because you'd be using the pin change interrupts.
Yeah, that's the only way this will work in practice. If you tried to pull this stuff, you'd end up with jitter all over the place.
Yeah.
Can't
So
you
these just tell you that a pulse is present. It doesn't tell you what the width was, right?
Sorry, say that again.
You do the leading, you get the edges with a pin change. You have to determine whether it's high or low. But
What was your question?
Every transition will give you an interrupt.
Ray, what was your question?
Okay, on top you've got those pulse widths can vary, right?
Yes, correct.
Yeah. But in the pulse position, they don't vary, right?
Yes, they do.
Oh, they do.
The width of the pulses doesn't vary, but the distance between them varies.
Oh, okay.
That's the position information, not the pulse information. That's what's different about this. Okay, so you start this pulse at the leading edge of this one.
Yeah.
You start this pulse at the leading edge of this one, which is also the trailing edge of the first channel.
Yep.
So the distance between the first pulse and the second pulse represents the width of the first channel.
The first pulse, yeah. Okay.
It's actually pretty slick.
Falling edge to leading edge is your pulse width.
Yep.
Hey, Tom, is that the way that the RF gets generated
Say that again.
on the transceivers and on the receiver and the transmitter? Is that basically what the RF looks like? Pulses?
Well,
And
it depends.
it goes into the pulse width modulation?
The short answer is no.
Oh, okay.
Because this is sitting on a 2.4 gig spread spectrum, cyclic redundant. It's got all kinds of crap in it to prevent interference on the 2.4 gig RF level. So,
Right.
So there's a huge amount of various modulation mechanisms occurring here to make all that happen at 2.4 gig. And you can eventually get this out the other end, but it's not trivial. Back in the mid 70s, I used to build these receivers myself with a bunch of other guys, and we built them out of TTL, individual low density TTL circuits and transistor-based RF receivers. And my God, they were simple. They were 27 meg wideband amplitude modulation.
Okay.
The only way that you avoided interference was lots of power. Anyway, they were a whole different aspect. We had no money, so we built our own.
Yeah.
So anyway, this is terrible. I mean, I've got a project, but then all these sub projects spin off.
Yep.
Okay, stop sharing. There it is.
Thanks, Tom.
You're welcome.
That's interesting.
Well, I'm going to be updating my Pi 5 to have not NVRAM on it or the NVM modules. And I was thinking of using the WaveShare hat for the SSD. I mean, for the NVM modules. I know that Doug has done that before.
Yeah. I think, Mike, just the one thing you want to make sure you're doing is look how some of them use a lot of the pins that are on the IO board, and other ones don't.
Mm-hmm.
And you probably prefer one that doesn't, so that you can you can use the IO freely. You know what I'm saying? Otherwise, if you see some of the hats, half of the IO port will be covered because they're using essentially the power to supplement the power that's coming through the little ribbon.
Right.
Okay, so picking the hat that you want, you just need to be careful.
Yeah.
There's some really good hats out there, and there's some hats that aren't so good.
Mm-hmm. Right. Yeah, the wave share sends all the pins through, and it taps off of the I2C to read some statistics or something. If you wanted to do that on the Pi.
Yeah, I'll tell you what. If you don't have one, I would recommend WaveShare makes a dual channel one. Okay, and the reason why you want the dual channel is someday you're going to want an AI hat. Okay, you're going to want an AI module to put in the other channel. And so you might as well get the dual channel now when you don't own any, as opposed to buying a single channel. And then when you get finally, the AI hats become available, that you have to go ahead and buy another one. So I would go get the dual channels, and WaveShare does make a really nice one. Give me a second, I'll show you the one. Okay.
While we're waiting, does anyone else have something they'd like to ask or present or?
So if you pin me, Mike, and take a look at this. See, it's got 2 channels on it.
Yeah.
And it's called a Gen 2. It's called PCIe to 2-channel M.2 hat plus. What's the other thing under there? I can't read it. This is their 2nd generation board, but it is a WaveShare board.
Yeah. How does it do cooling? Does it block the cooling a lot?
Your cooler is still under there. See my cooler down?
Yeah.
Right.
You know, I did have to put a little higher lifters than that came with the package, but that's partially because this one, to access the IO port, you have to put in an adapter underneath it and then squeeze it down. My first adapter I tried to get wouldn't go through the holes in the board, but I did find one that did. So this particular one this one actually has the Pi cooler, the standard Pi 5 cooler. You know, most of my coolers are not Pi 5. They're Pi 5, but they're special. They're not Pi. You know, there are other vendors who make coolers that look just like this cooler. Yeah. So, but this one, this is the official Pi one. So, yeah, it works real nice. And you see how they bring it down through the center here, so you don't have the big little loopy poo on the end. That's
nice.
That's kind of nice, you know. So anyway, that's the one I would recommend, even though this guy is a bit of a pain to find the right one, and you may have to put a small lifter.
Is that one of those solderless headers that you don't solder it in, right? It's like a press fit. Yeah,
it just squeezes, and it has long leads on the other side. The problem, the one that that's on the board, is that it is a gripper type, like you're saying, right?
Yeah.
So if these pins are a little on the wide side, a little bigger than the holes, you'll never get that sucker on. So you just have to buy one that fits. Now this one I got because it had these cool labels on the side. I don't know if you can see the labels.
Yep.
Yeah, but it's all labeled out. So in theory, you know, if I put the 5-volt thing on ground, it's my fault because I didn't read the label. So, but it's kind of cool. Yeah, this is the one that eventually will have the AI hat. Yeah.
So performance-wise, what do you think they're getting to? Is it like, you know?
It's not very. I'm sorry. What?
Oh, just performance-wise, I always, you know, is it as fast as an older i5 laptop, or
No, I don't know, but
you don't think so?
but it really does speed up file operations and things like that, and startup.
Mm.
And I mean, it doesn't. I don't think it really increases your compute time, but
Oh,
it
you don't
does.
think so? Yeah.
I don't think it does. Now the AI hat, it's got.
Hopefully will.
It will do. It has another processor in it.
Right.
Okay. Now the reason why this one's, you see, this kind of overcomes that problem I was telling you, in the sense that it is borrowing 5-volt processor, 5-volt power, and there's also a chip on here that's an I2C chip that monitors the power bus.
Mhm.
So you do get, on this particular board, you actually get a little freebie there where you can monitor the current and the voltage on the 5-volt bus.
Hmm.
So that's kind of cool. I tell you what, I'll try and find the link for it, and I'll put it in, Mike, so you can at least look at it, see if you like it. So let me drop off here and do that.
So I think that, I think this is it. Like, it looks like it's 5 gigabits.
Max.
I just, this past weekend, I upgraded my laptop machine with some of that stuff, and it's been a while since I've actually opened up a PC and done anything with it. And I went into Micro Center, and I got one, this SSD that I had, upgraded my 256 gig. I upgraded it to 2 terabytes for $115.
Whoa.
Toledo. And no, I said it gets better or worse depending on what you think about it. I can fit 3 of those things in my current laptop. And not only that, they have an inland in stock that if I wanted 8 terabytes per stick, it's only $950 for 8 terabytes of disk space. That's just insane, man. I mean, I remember growing up, that'd been the whole world, the entire internet, at one point. It's crazy.
The really scary question is, what's being stored on it?
Yeah, exactly.
Oh,
I remember, I imagine I could fill it up, but I have no idea how long it would take me,
Used to have a 10 meg hard drive that I thought I could never ever fill.
Yeah, exactly.
Now download a 10 meg file in a matter of seconds.
Yeah, if you blink at the wrong time, right, you've missed the whole download thing, right, Pat?
Yep. I still believe in Bill Gates, though. 640K ought to be enough for everybody.
It ought to be enough for everybody.
Well,
There's a cat on YouTube. His name is Dave Plummer. He's an ex-Microsoft employee. He built the Windows 95 start menu, or was one of the people that was responsible for its creation and a few other things. And so he has a pretty interesting YouTube channel. He'll get on, he'll give you some inside dope as to how some things came across and how some things came to be what they are, and those sorts of things. So, I mean, it might be something you want to look up every now and then to go in. And his videos are good. They're straightforward, and he has an okay delivery of the thing. He's like DroneBot. He's like the DroneBot Labs, but he's actually he does have some personality that he throws in there, and so it's a pleasant thing. But he has the kind of information about this is the case, that's the case, that kind of stuff. And his videos are shorter, but anyway. Sorry, I didn't mean to talk over anybody too badly.
Well, is there anyone else that has something to present, or are we done for the night?
I second
guys.
the motion.
Second the motion. Thank you, everybody, for coming out.
All right, thanks. Thank
Very
you.
good.
Thanks for the info.
See you guys next week.
All right, bye.